In geometry, a very important shape that we come across a lot is the triangle. Now, triangles are three-sided shapes, and the part of the word tri over here means three, and we see tri in a number of other words, trinity, for instance, and that indicates the three. And so another thing with triangles is that there are three internal angles. And these are internal angles. So the angles that you find within a triangle are the internal angles, and there's always three of them. Now there's different types of triangle. There's four basic types of them. This is a strange name, a scalene, it's called. And a scalene, each side of the triangle is of a different length. So this length and that length and that length are always different. And because the lengths of the lines are always different, the angles always are different from each other. So you don't find the same angle in another part of the triangle. The second type of triangle that we come across also has a strange name, isosceles. And the isosceles triangle has a number of characteristics in that two sides are of the same length. So this is an isosceles triangle, and you see that this length and that length are the same length. And it's always indicated by these little bars that go through the line. So whenever you see anything like that, it means that those two lines are of the same length. And because those two lines are the same length, then the two angles inside are also the same. So this angle is the same as that angle. The next triangle that is really popular is called the equilateral triangle. And equi sounds something like equal, which is where it's come from. And an equilateral triangle, all its sides are of the same length. And you can see that in these little bars over here that you find. So that shows that they're all the same length. Because they're all the same length, all the angles are the same. So we can work out what one angle is, we know what the others are. And the final type of triangle that we come across is something called right angle triangle. And with the right angle triangle, not all the sides needs to be are the same. You can have a few where it is the same length. But the thing with right angle triangle is that it has a right angle. And we know that this is 90 degrees. So we know one of the angles inside of a triangle. Something really important to remember with triangles is that the three angles which you find within a triangle always add up to 180 degrees. Now, isn't that useful to know that in this triangle, this one, that one, that one, all add up to 180 degrees? And can't see the top of this one, but this angle, and the angle at the top, I'll put the mark there, they all add up to 180 degrees. These ones, 1, 2, 3, these add up to 180 degrees. And if you look at this with the right angle here, and this angle and that angle, if you measure each of these, this adds up to 180 degrees. So it doesn't really matter the type of triangle, all the internal angles always add up to 180, which is really very useful to know. So here, before we have a go at working out one of these, when referring to angles, there's a certain convention. So these lines represent dissecting lines, intersecting lines. So there's that line there, that line there. And where they intersect, you find an angle, which is here. Now this line is known as AD, AB rather. This line is known as AC. So the angle that you find between them is often referred to as BAC. So that's BAC. And then the angle that you find between them is the one. Now, if these numbers had been changed to something that was a D and that was a C, and this was a B, then the angle would be DCB. So always watch out for the lines. It's always labelled in questions. So armed with that information, all the information that we've just covered, let's have a go at working out some of these things. So here we have a triangle, and because it has this sign here, it means it's 90 degrees, and this is a right angle triangle. Now with triangles you can extend the bits, so this looks as though it's sort of sticking out a little bit, and this bit may not be there, but it certainly helps us in working out angles, because the sides that make up an angle are always straight lines, so we can always extend those lines when we do our calculations. So do you want to have a go with this? And the question is, what are the values of m and n? So if you want to spend a little bit of time working that out, put the video on pause as usual, and I'll see you in a second or so. So let's give this question a go. So what is the angle m? So we can write this out as m degrees equals. Now how many angles here do we know? Well, we don't know this one. We know that one because that's 90. And we know this one. So where there is one unknown and two knowns, we can work out two or more knowns. We can work out what the unknown is. So here we go. So we know that all the angles inside a triangle add up to 180 degrees. If we took away 90 degrees and we took away 50 degrees, then we should come up with the answer for m. So it's 180 minus 90 and 50 are 140 degrees. 180 minus 140 gives you 40 degrees. So m is 40 degrees. How about n? How would we work out n? Well, with n, in a previous video, we found out that a straight line is 180. So if we were to draw in this would be 180 degrees. So in order to find out what n is, we need to take away 50 from it. So it's 180 degrees minus 50 degrees, and that equals 130 degrees. So n equals 130. And I hope you got that right.